Hello and welcome to this episode of SPSS one-on-one series with Warrior Analytics. Today we look at modified Poisson regression analysis. What is modified Poisson regression analysis? Previously we've seen how to run a Poisson regression and other types of regression, but what exactly is modified Poisson regression? To understand this, let's first consider a 2x2 table where you have disease status, whether people have disease or do not have disease, versus an exposure status, whether they are exposed or not exposed. This is a very common table in epidemiological studies, and here, if you have such a kind of table, where A represents people who are exposed and got the disease, B represents those exposed but didn't get the disease. C represents those who were not exposed but still got the disease. And D represents those who were not exposed and didn't get the disease. And this is a total of those who are exposed and those who are not exposed. From such a table, you can calculate the odds of disease in each group by just getting those with disease over those without disease. You get odds. Even in the unexposed, you can get their odds and get a ratio, call it odds ratio, by dividing this over the odds among the non-exposed. Usually you will see AD over BC if they are cross-multiplying, like AD over BC. But still in this same table, you can calculate the risk of disease among the exposed, where you get those who got disease over the total people who are exposed. That's the risk of getting a disease among the exposed, but you can also calculate the risk of getting disease among the non-exposed. Okay, that is now C over the total number of the non-exposed. And then you calculate a risk ratio, where you get risk among exposed divided by risk among the non-exposed. There is an element of what we call a rare disease. For a rare event, if you have a rare event, you will have smaller numbers of people who have the disease. And in such scenarios, A and C are very small, hence odds ratio approximately equals to the relative risk. What we mean here is if A is very small, then it means A over B will be almost the same as A over A plus B, because A is very small. And a similar thing, if C is very small, then C over D will be the same as, or almost the same as, C over C plus D. Because C is very small, this number is almost the same as D. So for rare events, we have this equation approximating to this equation. And then odds ratios are a good approximation of risk ratios. That's for a rare event. Look at an example where you have 200 participants, and among the exposed there was only one, and the non-exposed only 2 people got the disease. So in total you have 3 out of 200. If you calculate odds ratios here, you would get 0.49. If you calculate here, you will get 0.5. Very close values. Odds ratios approximates the relative risk. So the other thing, when you have a rare event, the binomial distribution, like the one for logistic regression, which gives you odds ratios, approximates the Poisson regression or distribution, which gives you relative risk. But let us look at scenario number 2. Still you have 200 participants, but among the 100 that are exposed, 25 got the disease, and among the non-exposed, 60 got the disease. This is already 85 instead of 3 in the first place. So this is not a rare event. When you try to calculate odds ratios, you will get 0.2. Relative risk, you will get 0.42. Odds ratio does not approximate well with the relative risk. That is for a rare event. Okay? So it means, so for a non-rare event, these values are big. Your prevalence is big. And so odds ratios are not approximating the relative risks. But still, we would like to have a model that gives us relative risks because they are easier to interpret for almost everyone. So we utilize the Poisson distribution, but since it has a limitation of overestimating standard errors when the outcome is common, we use the robust variance estimations while running that Poisson model. So we use the normal Poisson model, but we use robust standard errors, hence the word modified Poisson regression. So a modified Poisson regression is basically a normal regression, but utilizing robust standard errors to avoid overestimation of the standard errors of the parameters. If you found this video useful, consider liking and subscribing to the channel that you don't miss out any of the episodes that come.